Welcome to Punsirol Science. Today's topic of the tutorial is on electrical resistance of conductor, and I hope you will enjoy watching this video. So let's go. Electrical and electronic systems rely on three basic materials such as conductors, semiconductors, and insulator. Among them, conductors have the lowest resistivity. Conductors are used as power transmission lines in electrical system. In electronic communication system, they are used as signal transmission lines. They also help in interconnecting billions of tiny electronic devices in integrated circuits. Semiconductors are raw materials needed for fabrication of tiny electronic devices used in modern electronic gadgets such as computers, mobile phones, etc. Insulators are bad conductors, so they are mainly used for the purpose of ensuring electrical isolation and protection to conductors and electronic devices. Details of semiconductor devices will be covered in future tutorials. So let's go directly to electrical conductors. Materials that allows electric current to flow through them are called electrical conductors. These materials are either elemental metals or metallic alloys. A conductor contains trillions of free electrons, atoms, ionized atoms, along with some defects and impurities. Neutral atoms become positive ion after losing electrons due to a process known as ionization. Metal atoms have lesser ionization energy, so there are large number of free electrons inside a conductor. These free electrons make metals good conductors of electricity. If a battery is connected across a conductor, free electrons begin to move along a particular direction. The flow of free electrons over time gives rise to electric current. Trajectory of moving electrons changes quite often due to collision with ions, atoms, defects, and impurity. The collision leads to disturbance and hindrance to the flow of electrons, which is manifested in the form of physically measurable electrical resistance. Electrical resistance of a conductor can be reduced by lowering its temperature. Mercury is liquid metal which conducts electricity in the similar manner as other solid metals do. Now you have learned why metals are a good conductor. But an important question that remains to be answered is there any non-metallic material that can also conduct electricity? Now let's see the answer. Graphite is a non-metallic material. It conducts electricity due to presence of free electrons which do not take part in chemical bonding of carbon atoms. Salt water also conducts electricity due to presence of mobile sodium ion and chlorine ions in the solution. Ionized gaseous medium can also conduct electricity. Up to this point, you have learned the basics of conductor and the root cause of electrical resistance. Now let us see how can we determine resistance of a given conductor. Mathematical equation of resistance of a conductor is given by Poilet's law. Poilet's law states that resistance of a conductor is directly proportional to length of the conductor and inversely proportional to cross-sectional area of the conductor. And the constant of proportionality is known as resistivity of the conductor. And this parameter is different for different materials. So that is why resistivity ρ is also known as specific resistivity. In order to determine resistance of a conductor, the length of the conductor should be measured along the direction of current and the cross-sectional area should be measured in a direction perpendicular to the direction of current. This graphical plot shows how the resistance of a conductor varies with length of the conductor and cross-sectional area of the conductor. In the left-hand side, resistance increases linearly with length of the conductor, but it reduces non-linearly with cross-sectional area of the conductor. Resistivity of conductor depends on the type of material, impurities present, and temperature of the conductor. Resistivity is also equivalent to resistance of a conductor when the volume of the material is reduced to unity. As you have seen here, according to Poilet's law, this is the formula for resistance. If we have to consider a material of unity volume, then resistance R will be definitely equal to rho because L and A cancel out. The reciprocal of resistivity is known as conductivity, and conductivity is denoted by sigma. Sigma is equal to 1 upon rho. This table shows resistivity of some of the common metals at room temperature. Silver has resistivity of about 1.59 into 10 to the power minus 8 ohms meter. Similarly, nichrome has resistivity of about 1.0 into 10 to the power minus 6. And the order of resistivity for insulator, semiconductor and conductors are given here. So this order shows that semiconductor lies in between conductor and insulator as far as their resistivity and conductivities are concerned. Electrical resistance of conductor increases with temperature. The reason is that inside a conductor, metal ions, atoms, defects and impurities vibrate about their mean position even at room temperature. The amplitude of their vibration increases with temperature. This condition leads to increase in rate of collision with free electron. Effect of temperature on resistance of conductor can be quantified by using the formula given below. In this equation, RT is the resistance at temperature T, which is greater than T reference. R reference is the reference resistance at temperature T reference, and alpha is the temperature coefficient of resistance. Alpha is normally positive constant for metals. So the increase of resistance with the rise of temperature can be explained based on this mathematical equation. Different conductors have different values of resistance depending on the value of their resistivity. Some conductors have very small resistivity, while some others have very high resistivity. Now the question is, do we need only those conductors having very low resistance? Let us see the answer. Low resistance conductors are used in power transmission and communication system to minimize power loss during transmission. Conductors such as copper, aluminum, etc. are commonly used metals for these purposes. Nichrome and tungsten have much higher resistance as compared to silver, copper and aluminum. Nichrome is used in electric heater to get better heating effect, whereas tungsten is used in filament bulbs to get better light emission. So the above points have shown that we have to use different conductors having different resistance depending on the type of applications. Now let us see how the resistance of a conductor can be measured practically. Resistance of a conductor can be measured by traditional methods based on Kelvin double bridge, Wheatstone bridge, and modern methods based on Ohm's law. Ohm's law will be discussed in my future tutorial. Well, I have described basic fundamentals of electrical conductors and their resistance. Now let us see if you could answer some of the questions given below. I hope you will be able to give answer by yourself after watching this video over and over again. Of course, there will be some questions that you won't be able to answer. And if you are really interested, please write about those questions in the comment box. And definitely I will write back to you. Obtain the mathematical equation of resistance for the following conductors: solid rectangular conductors, hollow rectangular conductors, cylindrical conductors, and hollow cylindrical conductors. Can you think of a method by which you can determine total length of a very long conductor even without stretching its entire length? Calculate resistance per kilometer for a long aluminum wire based on the following parameters. Assume that diameter of a conductor decreases by 50% when its length is increased by 50%. Find the percentage of change in the resistance of the conductor. How do electrons behave inside a conductor under the following cases: in the absence of electric potential difference, in presence of electric potential difference? Why do metals have positive temperature coefficient of resistance? So that resistivity of a conductor at temperature T can be expressed as given below. How does salt water conduct electricity, whereas sugar water does not? Graphite is a non-metallic substance. Then, how does it conduct electricity? Which metal has the lowest resistivity? Name the element which is a liquid conductor at room temperature. Nichrome wire is used in electric heater. Why is copper not used? Under what condition A gaseous medium can conduct electricity. If you convert a long straight wire into helical structure with several coil windings, what may happen to the total resistance of the wire? Silver and gold are not used as conductor in power transmission system, although they are good electrical conductors. Why? So thank you for watching this tutorial. You can ask me any question on the topic in the comment section. So in my next video, I will give you a tutorial on series and parallel combination of resistance. So please stay tuned for the next video. If you find this tutorial video useful to you, please subscribe and share the video with your friends. Do not forget to press the bell icon in my channel to get the latest update. Thank you all.